Assalamu alaikum. In this video, we are going to see the problem D of Codeforces Round Deep 1017 Deep 4. So, in this video statement, in this problem statement, they have given us two drums in front of you, a left drum and a right drum. When we hit the left drum, it was recorded as L, and when we hit the right drum, it was recorded as R. So the strange forces that rules in the world are fickle. Sometimes a blow sounds once and sometimes it sounds twice. That means if we hear LL or L, we can say that we hit a left drum, and then when we uh, hear the sound once or twice, we can say that the right drum was hit. So here the sequence of hits made is recorded in the string P, and the sounds heard are in the string S. Given P and S, determine whether it is true that the string S could have been the result of the hits of the string P. So in the example, if P equal LR, then the result of the hits could be any of the string LR, LLR, then LLR, and LLRR. That means if we see that one L, then we can get one L here. If we see one R here, then we can say that one R can be here. Then if we see one L here, we can say that one L should be present here. Then we see that here 2R is present, and from 2R we can say that we hit the right drum once. Then in the LLR, here there are 2L, and we can say that in the P we can write 1L here. Then from 1R we can write 1R here. Then from LLRR, from this 2L we can write 1L here. Then from this 2R we can write 1R here. Okay, but in the LLR we can write from 2L this L, but and from this R we can write R here, but this L is left. So this is not the case. This should not be satisfied. Then LRR, in the LRR, L, from this L we can write L here. Then from this R we can write R here, but this L is left, so this is not going to be accepted. So now from the test cases, from this to R we can write R here. From this L we can write this first L, then second R we can write this R. Then from this L we can write L. Then from this R we can write R here. Then from this 2L we can get this L, but this L left behind, so it is not going to be satisfied. So the answer, the output is no. Then in this test case, from this L, from this first L we can write this L. Then from this L we can write the second L. Then from third L we can get the third L. Then from the fourth L we can get the fourth L, but this L left behind, so this is not going to be satisfied. Then this is in this test case is true, because we can get this L from this L. Then from this 2L we can get this L. Then from this R we can get 1R. Then from this L we can get this L. Then from this 2R we can get this R. Then from this 2L we can get this L. Then from this R we can get 1R. Then from this 2R we can get this R, and from this L we can get this L. So it is going to be satisfied. It is satisfied, and the output is yes. Okay. Now we understand the test cases. Now we are going to see how we can solve it. So this is the test case which was satisfied and the output was yes. So let's see how we can solve it. We at first we have to uh, assign two pointer in these two string. So we can indicate this as p and this string as s, and we can take two counter here, count 1 and count 2. Okay, then we have to do is we have to track the character from p. So we will take the first character of p here in the p variable. So the first character of p is l. Now we have to track the l. We have to check if this c is matched in the p. So we see that we will run a while loop. We'll run a while loop until the to run the while loop until the the index of p is not uh, same as c. So if we run a while loop from the first, so we see that the first index of p is l, so it is as same as c. So we can increase the pointer x in the next position. So the x will indicate, will point here, and we will increase count 1 as 1. Then we see that the index of p is l, and which is as same as c. So we will increase the count 1 as 2, and we will increase x. We will increase x by 1, and x will point here. Okay, then we see that the index of p, the index of p which was pointed by x is not as same as c. So we will stop here, and then we have to work for y. So for y we will see that the first index of s is as same as c. So we will increase y, and y will point here, and we have to increase the count 2. So count 2 will be 1. Then we will increase y, because this l is as same, this l is as same as c. So y will point here, and we will increase the count 2 as 2. Then in the next position, this l is as same as c, so we'll increase y as well. So y will point here, and now we have to increase count 2 as 3. Okay, now we see that count 2 is greater than count 1, and this is going to be satisfied for l. This l is come from this l, and this 2l is satisfied this. So we can say that when our count 2 is greater than count 1, the answer is going to be okay. So the first condition we get is count 3 must be greater than count 1. Sorry, count 2 is must be greater than count 1. But if we see another test case, if we see the test case LL R R L, and this is our P, and another, so LL, then R R L. Okay, so this is not going to be satisfied, because this L can come from this 2L, this L can come from this 2L, but this L is going to left behind. So here we see that our count 1 will be 2, count 1 will be 2 for this, but count 2 will be 5 because here L is 5. So we can say that this L is left behind and the count 2 is greater than 2 into 2. That means whenever the count 2 whenever count 2 is greater than count 1 into 2, we the answer must be no. Okay, so these two conditions must be satisfied. So we can say that when we get our output no is count 2, when count 2 is less than count 1, the answer will be no. And whenever count 2 is less than, count 2 is greater than count 1 into 2, we can say that the output will be no. So now if we see the implementation, here is the implementation. At first we take the input s1 and s2 for two string, then we take two pointer x and y. Initially it is 0, then we take a flag, then we run a while loop until x less than s1 dot size and y less than s1 dot size. Another one I missed out, that is when the p and s is going to satisfy, the x should point to this L and y should point to this L. Then we can say that our two string can be satisfied. So this condition is must be satisfied as well as these two. Okay, so now if then we take count one variable as for count, then we take character p equal s1 of x, then while x less than s1 dot size, and our s1 of x, the x is pointed at s1, the position must when the position is equal to p, we increase the count 1 and we increase the x pointer. Then we take count 2, then when these conditions are satisfied, we increase count 2 as well as y, and then we check these two condition. So when one of the condition is going to be true, we can say that our output is going to be no. So here when one of these two condition is going to true, we set the flag as 1 and break here. Then after while loop, we check if our x is pointed to the last position of s1 or y is pointed to the right to the last position of s2. When these two condition, one of these two condition is false, we set f equal 1, and at the last we can say that when our flag is going to be 1, the answer must be no, and else our answer must be yes. Okay, if we run this and our test case is passed. So I hope you understand this problem.